with our loops, and then I will introduce you the idea about arrays. Let me just briefly talk about your lab test 2. So we have, let me just briefly talk about it for lab test 2, just to give you some perspective. Okay, guys? Okay, for lab test 1, basically you have things like utilities, and also on the other hand, you also got utilities tester. That's what you got with the main method, right? And then you'll be given lots of example value to actually guide you through your implementation. For lab test 2, this format is going to be exactly the same. The only difference is for the utilities class, the methods you're going to implement will be slightly harder in the sense that, for example, let's say we may have, an excessive method returning integer average. And then in your lab test 1, I simply give you exactly how many integers, right? Like a 5 integers or 4 integers. In lab test 2, what you will be given is simply something that looks like this. Okay, don't panic too much. This is the notation that I'm going to introduce to you today. It's something called array. So to really implement this kind of method, you need to use array and also loops, for loop or while loop. That's something exactly we have been covering. And then I will cover today, and also we got a gap of reading week, and then we got another lecture before the lab test. So I'll try to cover as much as possible today, and then I'll give you the example lab test 2 by Friday this week. So you got more than 2 weeks to prepare. Okay? That's kind of where we're heading to. And then for your lab test 1, I'll try to release your marks, hopefully soon after the reading week. I'll try. Okay? Okay, so now what I would like to start with is the selections lecture very quickly. There were some slides which I left over from the previous lecture, which I want to go over very quickly. Okay? And then we'll continue with the loops. But hopefully this one over here is actually much easier for you right now. Let's just look at that as a case study. Okay? So if you go to slide 19 of your selections lecture, okay? So now, basically, the goal of this slide is we want to compare these two fragments of code. Okay, guys? We want to compare these two fragments of code over here, and somehow we want to know that if they are really equivalent or not. We are not going to do any formal proof. That's not what we're going to do. I just want to give you some intuition about how you should understand these two fragments of code very quickly. Let's just understand one by one, okay? So the left part over here is now on the iPad. Let's have a look at that. Now, basically what we want to do is, let's say we want to print out the letter grade for the numerical marks. It can be either A or B or C or F. Okay, that's kind of the output. And the way we program that is by doing this. First of all, we want to understand the syntactic structure for this fragment of code. How many if statements do we have overall? Do we have only one, right? Let's look at that. You can see that we have this single if statements. We have if and we have else. Okay, that's a single if statements. We also call this compound statements in the sense that inside either of the branches, you can try to have nested if then else. And later on, we'll see that in general, you can even nest loops inside your if then else branches. Okay, but in this case, you can see in the if part, we say that if the score is larger than or equal to 80, and then we're going to print out A. That's the if branch. The if branch over here is very easy. Okay. What about the else branch over here? So now under the else branch, we want to know how many if statements do we have. Similar, right? If you look at the structure there, somehow the indentation of the code suggests how you should interpret that. So now let me use a different color here. You can see that for the else branch, we got also one if statements. And then we have the if over here, and we have the else. Okay, if and else. What about the if part? For the if part, we say that if the score is larger than or equal to 70, and then we're going to print out B. Okay? And then over here, under the else branch, we just got another if statement over here. Let me use one more color. Let's say pink. And then we got just another if statement over here, right? It's also the body for the else branch. So we got either if or else. Okay, that's syntactically how it looks like. Okay? Let me just jump to the right-hand side right away, and then I'll just explain to you intuitively why these two alternative syntax are actually equivalents. Okay? Okay, the second one over here. So now let's have a look at this. This one seems to be much simpler. It seems to be. So now again, we got to ask ourselves this question. How many if statements do we have? It's just one, right? You can see basically we have only one if statement. However, remember we can have as many else if as we like for any single if statements. So we got if, else if, and then finally the default case is else. So you can see structure-wise, the two if statements look very different. Okay, very different. But now you can see that we say that if the score is larger than or equal to 80, then we're gonna execute a branch over here. Else if this one evaluates to false in case, then we're gonna go ahead to the next one, and then to see if this one is true or false. If it is true in case, we're simply going to execute this branch of code and then ignore all the rest, right? That's how we learn about if statements. Okay. So now let's have some very quick check on the both sides. So now what I want to try is the following input. Let's say we got 75. Okay, let's say try 75. Let's say the score is simply 75. What's going to happen here? Okay, if you got 75 over here, 75 larger than or equal to 80 is false. That means we ignore this branch over here. And then we go to the else part, and the else part contains just another if else, right? And then we check this if branch over here, and then score is 75. 75 larger than or equal to 70 is true. That's why we'll execute this branch over here, B. Let's try to see how the same input is going to trigger the program to behave. Let's talk about the same input over here. Score is 75. Let's say the same input. What's going to happen here? If you have the score being 75 over here, 75 larger than or equal to 80 is false. So that means we bypass this particular branch. And then we go to the next one, the else if. Now score is 75, larger than or equal to 70. So that's why that's true. So that's why we execute this one here. So you can see even though the two fragment of code looks very different, but semantically speaking, the meaning-wise, they are really the same. Okay? But which one would you prefer? It's completely up to you. But I personally might prefer this one over here. It's much neater, right? Because in this one over here, I want to say one more thing. Whenever you say if some condition over here, C, some Boolean condition, and then I say else. Okay? There's something very important for you to realize logically. If I try to check this logical condition over here, and then let's say somehow for any reason it evaluates to false. So that means I bypass this block of code. And then I try to execute whatever is inside this else branch. But there is some implicit assumption you should know about, which is we know that it is not the case that C is true. So this will actually help you later on how you can trace the code. Okay? Similarly, if you look at this one over here, if we got if C, and then we do something here, and also else if. And then we got, let's say C1 over here, also C2. C1 and C2 are any Boolean conditions, okay, and etc. Let's say this. Let's say first of all, we check this if condition here for C1 and evaluate to false. So that means we're going to bypass this branch of code, and then we go to here. Before we check C2, what do we know about? We know that it must be the case that implicitly it is not the case that C1 was true. Not the case. Otherwise, we would have executed this branch already. Okay? So that's kind of the intuition I would like to give to you. But somehow these two fragments of code, even though they look very different syntactically, But meaning-wise, at the runtime, they really execute to be the same program. That's something I want to show you. Okay? So that's some example I left out from the previous slide. Okay, so this one here. Okay, another one. So this one is already very easy for you, I think. But let's just go over it anyways on your slides. So now what I want to do is, you can see that over here, we have another single if statement here. We have if, we have else if, we have else if, and there's a missing else. So now in general, it's actually not so recommended if you have a missing else. It's not so great. Because that means if all the conditions over here, if they happen to evaluate to false, that means you have no resolution to this kind of situation over here. But now, in this case, are we okay though? Can you give me a score which is going to fail all the 3 conditions over here? 45, okay, that's good. It's pretty much similar to 55. Okay, let's say 45, okay? Let's try 45 as a score. 45 is going to make larger than or equal to 80, false. And it's going to make larger than or equal to 70, false. And also this one false as well. That means we have no branch to be executed. But now in this case, what's going to be the value for letter grade? F. Now it's simply because we assign this to some meaningful default value. To say, if we have no chance to reassign the letter grade to be either A or B or C, keep it F. Intuitively, if a student is neither A, B, nor C, they should get F. Okay? So now, so this is the general principle I want to tell you. If you have missed the else branch, make sure your variable is initialized properly. Your variable is initialized properly. Okay, in this case, we initialize that to F. Okay, just for this case. Okay, that's a simple example. Okay, anything else? Okay, one more thing. Let me just go over a few more slides. Okay, that was easy. I kept talking about primitive versus compound statements, but let's just go over very quickly about their definition. What does it really mean to be primitive? What does it mean to be compound? So what is a statement? Whenever I say a statement in Java, I mean I have a simple assignment over there for us to modify the variable. You have the left-hand side, you also have the right-hand side, the source and also the target, right? So now, for the statements, it can be either primitive or it can be compound. Okay, either primitive or compound. So what does it really mean to be primitive? The definition is easy. The only primitive statement we have in this course is an assignment. You want to assign some source value into some target value. Very simple, just a single variable to be modified. However, things can get more complicated if you want to modify more than one variables, or you want to say, I will only modify this variable conditionally. Or later on, we might say we want to modify some variable repetitively using a loop, right? So that's where things will go more complicated. But what I want you to know is, whenever I talk about primitive statements, I really refer to just assignments, okay? A very simple case. And then we also talk about compound statements. So in computer science, whenever you learn about some difficult concept, you always start with the base cases, the simple one, like what you did for mathematical induction in the high school. You start with the simple cases, and then you start with the more complicated cases. Okay, that's what. But then we'll gradually go over more and more examples. Okay, one more example for if. Let's have a look at this program over here. Okay, let's say over here. So this apparently, again, is a compound statement. It's a compound. Compound because it's not a simple assignment only. It's actually selective. Okay, you can see that we have one assignment here, and also we have a single if statement over here. For the if branch, we have another if statements, and also under the else, we also got another if statement here. And before that, we also got a print statements. And in the if branch, you also got a print statement. So it's compound. It can be as complicated as you might need for your problem. Okay? So now you can feel free to try different values. How about let me say I give you one little bit example here. Can you give me a value? Problem here. Question. Give a value of x such that line 11 is executed. Give me a value for x. Can you give me one value? Negative 6, maybe? Okay, let's see. Let's try to think about how I can derive the answer. Let's think a little bit more logically. So now, we know that in order for you to execute this line over here, that means we must be in the context of this else branch. If we are in this else branch, what does that mean? That means the if condition over here must be false. What's the negation? What's the negation of x larger than or equal to 0 mathematically? Well, we know that is simply equivalent to x less than 0, which is exactly what I put over here. That's why I want you to always think about when you have an else branch or else if, think about what it really means implicitly. It must mean that the previous check must be false. Okay, now after we know that it should be x less than 0, and then we want to make sure not only that x must be less than 0, but also x is less than minus 5. In this case, if I try minus 6, that's going to make it work, right? And then we're going to say y is assigned to minus 6 multiplied by minus 1, which will give you 6. Okay, so just another example to show you compound statements. So what we will do for the next few weeks, we'll see very complicated loops structure, where inside the loop, you might have another loop, or inside the loop, you might have another if statements. So that's something you have to gradually get used to, okay? Any question until now for the if statements? Okay? Okay, let's continue with the loops, okay? That's something we want to do as much as possible today, okay? Okay, let me just go back to the slides. I'll just, okay, I'll go back to the loops lecture over here. I want to go back to slide number 6. Okay, slide number 6. And then let's continue from there. So we'll continue with our for loop. And then we'll introduce while loop in just a moment. Let's now review very quickly what we said last time, very quickly. So the very insight you want to have about for loop is as follows. You can see that, so last time we talked about how you should interpret each part of the for loop. That's something we talk about in details. That's something you should really review from the lecture. Let's say this. If we have some initialization over here, which is done only once, and also I less than 100, it is so-called state condition, which means as long as this condition is true, we're going to stay in the loop. And then I++ is somehow for you to make progress, to update the loop counter just a little bit at the end of each iteration. Okay, so the question I asked you last time was, how many times are we going to execute this line of code, the body of the loop? How many times, first of all? That's question number 1. And question number 2, how many times are we going to check this Boolean state condition here, I less than 100, right? So that's something we went over last time before we ended the lecture. So it turns out we know that the value for I will start with 0, which is going to make the state condition true. That means we enter the loop for the very first time. And the initialization is done for the very first time. It will never be done again. And then we can see that every time at the end of the iteration, we're going to increment the counter I by 1. So after the first iteration, increment from 0 to 1. Okay, keep going. 1 is also less than 100, so it will still be true. So we keep evaluating the value for this state condition over here, I less than 100. The question is, how many times are we going to get true? And how many times are we going to get false for this particular loop, right? So here's the principle. Since we know that the state condition means as long as the state condition is true, we're going to stay in the loop. As soon as it becomes false, we're going to exit from the loop. So that means we're going to have a series of true evaluation for the state condition. And then the first time that we evaluate the state condition to be false, we're going to exit. Okay? That's why in this case, for example, you will see that until we get 99 less than 100 still true. Now, as soon as we increment the value of the loop counter into just one more, in that case we get 100. 100 less than 100 is going to give us false. So that means it's now time to exit from the loop. So if you think about how many times are we going to evaluate the state condition here, is 100 times. So 101. You got 100 times, in which case you got true. And then the final time, the 101st time, you get false. And the next question is, given this trace over here, how many times are we going to execute the body of the loop? It should be corresponding to the number of times that we evaluate the state condition to be true, right? In that case, that'll be 100 times. Okay, so this is kind of something you got to make sure precisely. So I can simply just ask you how many times a loop is going to run. So that's really important to get right. Any question about this for loop here? Questions? Are we okay? Okay, let's continue. Okay, let's now consider for loops. So now again, so this is again some review. If I have this for loop over here, so you do have the freedom to actually move the initialization part outside and also move the update part to the end of the body of the loop. So this is completely equivalent to just like that. So that's also something I have illustrated before. So you can simply move whatever initialization over here outside the loop, and also you can also move this I++ to the end of the body of the loop. Okay? Okay. Any questions? Okay? Okay. So now let's think about the following question here. Let's have a look at this loop here. We say that we have a counter called count, initialized to be 0. As long as count is less than 100, we're going to stay in the loop and print out some message there, and then count ++ at the end of each loop. Okay, that's number one. And number two, let's say we do that slightly differently. Let's say we initialize and not, so let's say these two loops are complete independence. Okay, so here we got integer count now initialized to be 1 rather than 0. And then we say count is less than 201. And then the way we update the loop counter is rather than saying count ++, we say count plus equal to. So for example, let's say initially 1, and then 3, and then 5, and then 7, etc. until we get to the value that is larger than or equal to 201. So now the question is, do you think these two fragments of code are going to print out the same thing? I heard no? Yes? No? I'll give you a little bit hints. 2 hints over here. First of all, think about how many times each of the loop is going to run. That's hint number 1. And hint number 2, look at the body of the 2 loops. The body of the first loop, when we say welcome to Java, it seems like the output does not depend on the value of the loop counter count, right? Similarly, for the second loop over here, we also say welcome to Java, in which case the output does not depend on the value for count. Okay? So those are the 2 hints for you. Okay? So now, why don't we try to see how we can reason about this? Okay? 0 to 100. Okay, so let's now see that. Let's say for the first loop, for integer I0, I less than 100, and then I++. That's the first loop. And then we say print line, I'll say hello world. Okay, just make it short, hello world. That's the first one. And the second one there, let me be careful over there. Let me just close this. Okay, so the second one there is going to be 201. For integer I is 1, I less than 201, and then I plus equal 2. Okay, and the body of the loop is the same. Hello world. Okay, let's now think about these loops. You can see that first of all, the body of the loop looks just the same. Okay, that's the first comparison. Now the second comparison is as follows. Now that's why I try to review with you in the previous code over there. Okay, let me see if I can just close this one here. Okay, good. That's why I reviewed with you previously. So that's why this table over here is extremely important to see that exactly how many times you're going to execute the body of the loop. That's really important. We're going to apply the same knowledge, the same technique over here. Okay, let me see if I can just delete the desktop over here. Yes, I can. Okay, good. Okay, so now for code number 1, how many times to check? So this is the so-called state condition. How many times do we check the state condition? Okay, let's say this. I'll give you a little bit, let's see the pattern, okay? So we know that, let's say the value of I over here, and then we got I less than 100, right? Initially, I is simply just 0, right? I less than 100, true. Okay, and then we know that we'll keep incrementing I just by 1. You can see plus plus. And then 1, that will still give us true until what is the last value that will give me true? 99. Good. 99 and true. And then once you get to 100, it will give you false. So you can see, so these are the true value. How many do we have? From 0 until 99. 100. Okay, so now let's make a little mathematical, which is something you can easily do. So now you can see that, so these are the loop counter value, which will make the state condition true. Let's try to be a little bit mathematical with the notation you're familiar with. Closed interval. So that means starting from 0, we can get up to and including 99. That's a closed interval. And how many integers are there? It's simply 99, the end minus the start plus 1. You got 100. So that means you got 100 iterations. Okay, 100 iterations to move to go. Okay, 100 iterations. Okay, having this, if we know that we're going to have 100 iterations for this particular loop, so what does that mean? The output is going to be hello world, hello world, hello world for 100 times. Okay, that's the output for the first loop. Okay, what about the second one? Again, similar question. For the second one, how many times? So you can see that this is the state condition over here. Okay, and then we have how many times to check the state condition in this case. So that's the state condition. This is definitely trickier, okay? But we're gonna do that. It's just simple math. How many times to check the state condition? We know that I over here and also I less than 201. That's what we have, right? Think about this. So I start with 1, and then I less than 201, true. And then what will be the next value for I? 3, thank you. 3, also we got true, and we got 5 here, we also got true, and until, what's going to be the last value that's going to make it true? 199. 199, very good. 199, which is going to make it true as well, and then the next one is going to be 201, which is going to make it false. So now you can see that, so these are the true values caused by the loop counter value, which will be 1, 3, 5, and then up to 199. So what we are really trying to do is as follows. Let me do a little bit math with you. If we got 1, 3, 5, all the way to 199, exactly how many values do we have? Well, can you see? Okay. I'll tell you what, this is how I do it. You can feel free to do it another way that it makes sense to you. This is how I think about it. So we talk about I, right? What I would do is, mathematically speaking, it's nothing about Java, just math. Let's think about we got another variable called j. And I have the following formula to say that you can see I over here is simply 2 multiply the following formula. I'll write it more properly for you. Okay, so this is how I would like to define the relationship between I and j. Okay. So that means I is simply 2 times j minus 1. That's what I will get. Okay. So now, when j is equal to 1, what is I? I would be 2 times 1 minus 1. 1. When j is equal to 2, what is I? 2 times 2 minus 1, 3. If I got j is equal to 3 here, 2 times 3 minus 1, I got 5. And now, what's the last value for j? 2 times something minus 1 is 199. What's that something? 100. So now it's much easier. You do have the one-to-one mapping between these two values over here. So now it's much easier for you to see how many i's do you have. It corresponds to exactly how many j's you have, which is 100. Okay, this is just one example to show you that when you have tricky updates like this, I plus equal to 2, and also some tricky state condition, the way to do it, of course, it's going to vary from example to example, but there's one way to show you. What you're going to do is you're going to figure out exactly what are the loop counters for you that will actually make the state condition true, that will tell you exactly how many iterations you will have. And most of the cases, if you already got the numbers for the loop counter, you can do some simple trick in mathematics to actually make it easier for you to see how many numbers you have. Okay, so in this case, you got 100 numbers. Okay, just math. Okay, so now, given that, we also know that also 100 iterations here. Okay, so now for problem number 1, 100 iterations. Problem number 2, 100 iterations. Even though the initialization for the loop counters and state condition and updates, they're all different. But it turns out, because the body of the loop does not depend on the counter value, right? The counter value will be different because one is going to be 0, 1, 2 up to 99. The other one will be 1, 3, 5 up to 199. But since the body of the loop does not depend on that counter value, so you're okay. So it turns out these two fragments of code, they will output exactly 100 times of hello world. So they are the same. Okay? The next question is, how can I make it different? Okay? Guys, any question about this? It's really important. The main lesson learned from this example is, given different initialization, different state condition, different updates, you should be able to tell exactly how many iterations there will be. It's really important for you to trace the exact result. So now, if I go back to the slides, so now you will see that over here, for this particular one, it's really about comparing the two intervals, and we really got the same size, the same number of numbers in the two intervals, so they are the same. However, let's look at a slightly different example, slightly different. So now, you can see that it's basically the same. We still have a counter values initialized to be 0 and then up to 100, okay? And then, so now what we have is not just welcome to Java. Welcome to Java and some count value. So what's going to be the first line from this loop? Welcome to Java 0, and then welcome to Java 1, welcome to Java 2, until welcome to Java 99, right? So that's what it will do, because now the body of the loop depends on how what the value is for the count. So that can make a difference. Now, let's say we got another loop over here. So now you should be convinced that this loop here is going to run exactly 100 times, from 1 up to 100, right? So now, are these loops going to output the same thing? That's the question. Now, again, you have to look at two things. First of all, how many iterations do you have for each loop? They happen to be the same. Each one of them will run exactly 100 times by doing the same analysis I just did for the previous example. But now, since the counter value is going to be different, for the first loop, it's going to be, count will be 0, 1, 2, 3, 4, up to 99. And for the second one, it's going to be 1, 2, 3, 4, up to 100. So even though both of them will run exactly 100 times and printing out exactly 100 lines, but the line will be different. Guys, follow? Okay. Okay, shall I make it more precise for you? Of course, you can always try to run it. In case you really don't follow, let's do it over here, okay? Okay, let's say count 0, and then we have less than 100, less than 100 over here, and then count plus plus. Okay, and then we say print line. Hello world over here plus count. Okay, that's number one. Okay, that's the first example. The second one, we have integer count is 1, initialized to be 1. And then we say that count less than or equal to 100, and then we got count plus plus. And then print line. Okay, hello world plus count. Now, if you look at the body of the loop, they look the same. Hello world plus count. Hello world plus count. Syntactically speaking, they are the same. However, at the runtime, what's going to be the difference? Now, first of all, we know that the number of iteration for this one here is going to be 100. Because we got 0, 100 iterations. Because we're going to have count being 0, 1, 2, all the way to 99. Okay? And then, for this one over here, the second one is also 100 iterations. Because the count value over here is going to be starting from 1, 2, 3, all the way to 100. Now, you can see that even though they got the same number of iterations, but since we are using a counter value inside the printout, so it's going to make a difference, which means the first line that's printed out from the first loop is going to be hello world 0, and then hello world 1, hello world 2, up to hello world 99, right? What about the second program? You're going to start with hello world 1, hello world 2, hello world 3, and then up to hello world 100. Now you can see that exactly the difference is like this. This first line here is different, and also this last line over here is also different, right? So now what's the point here? The point is, whenever I give you any arbitrary two loops, I can simply ask you, tell me if the two loops are going to produce to me the same output. How do you judge? In principle, based on the initialization value and the state condition and the updates mechanism, you can figure out exactly how many iterations there's going to be. And then look at the body of the loop. If the loop of the body does not depend on the value of the loop counter, it's much easier, like the previous case. Otherwise, you may have to look at exactly how the loop counter is going to change. The count over here and the count over here, right? The count over here is exactly what we try to enumerate over here, and the count over here is over here. Okay? So study these two examples very carefully. Okay? So that's why I said last time loops can get very complicated, so we'll get into it. Okay? There are more and more logical complexity you have to deal with for the loops. Okay? Any questions for this? Okay? Okay, good. Let's now move on to the next one. Okay, let's try one more time. Why don't you tell me? Okay, this one should be easy. Okay, only numbers. What should be the output from this loop? 5 lines, yes. What will be the first one? 1, right? 1, 2, 3, 4, 5, agree? Good. What about this one here? This one, don't be so terrified by the fact that it actually has more lines of code. It's basically the same, right? I simply move out this initialization part into here, and this increment part into here. So, would it be the same? The same, right? 1, 2, 3, 4, 5. Okay, the last one is a little bit trickier. The last one. Let's be careful. So now we have initialization part, I is assigned to 1, and then I is less than or equal to 5, I plus plus, and then print line. I'm going to draw this on the iPad, but think about it for 30 seconds and tell me, first of all, how many lines there, how many lines first of all, and then what's going to be those lines. Okay, think about it. And meanwhile, I'm going to copy the code onto the iPad, so we'll go over that. Okay, anybody? How many lines? 4, 5? 4? Okay, I heard 4. That's fine. Okay, let me not say if that's right or wrong just yet. We'll trace that together. Okay, if you think that's 4, what would be the 4? 2, 3, 4, 5. That's a good guess, or that's a good answer. Okay, let's try. Without me saying if that's wrong or right, why don't we try? Okay, let's try that. Okay, this is loop, and then this is the initialization for your loop. Let's try that. So now this is I, and then over here this I less than or equal to 5, and then we'll try to print. I'll say P of I, which means print line I. Okay, let's try. I is initialized to be 1. 1 over here, 1 less than or equal to 5, true. That means we're going to be careful. Before we print it out, we're going to execute I plus plus, right? That means we're going to print out I plus 1. So I will be incremented to 2. So print I 2. And then when we go back to the beginning of the loop, we'll check again if I less than or equal to 5 is true or false, right? But now, which value do we use? Do we use 2 or 3? We should only use 2 in this case because remember, this case is a little bit tricky in the sense that we do the updates right in the beginning of the loop, right in the beginning. Okay? So now, once we get 2 over here, 2 less than or equal to 5 is true. And then, now what do we print out? Do we print out 2 or 3? 3, right? Because here we're going to execute I plus plus first. And then the I will become 3. So we print out 3. Okay, and then we use 3 over here to check. Right? You can see that the tricky thing is I plus plus is not occurring at the end of the loop. It's occurring in the beginning. Okay? And now for 3 here, 3 less than root of 5, true. And then increment I, 4. Print out 4, we got 4. Okay, and then no increment at the end. So we go back to the beginning of the loop. So we will have 4 over here. And then 4 less than or equal to 5, true. And then before we print out, we got to say I plus plus, which means it will become 5. So we print out 5. So far we got 4, 3, 2, 5, right? Which is what you said before. But let's see if there might be an extra line. Let's try to see. Now, you can see after this 5 here, there's no more increment, right, at the end of the loop. So we go back to the loop, state condition there, 5 less than or equal to 5, true. And then, do we print out 5? No, because we got I plus plus. In this case, I plus plus, you will increment I from 5 to 6, and we print out 6. And then we check with 6 over here. 6 less than or equal to 5, false. Okay, be careful, it's a tricky one. So that means we got exactly this many true values for your loop counter. That means we got exactly 5 iterations. That's why we got 5 lines. This one is tricky, but you should know how to trace. Guys, are we okay? 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 All right, very good. Okay, that's going to be 2, 3, 4, 5, 6. Okay, that's about the for loop, the fundamentals about for loop. So let's talk about another loop, which is called while loop. In some way, the while loop, the syntax is easier than the for loop. Let me just show you one example here. So now, first of all, the while loop, this is how a typical example. So now over here, you can see we say while something over here, and then we do something inside, okay? Let me just go back to iPad. I'll show you exactly how the syntax should look like, and also how you should understand how to trace the while loop. Okay? So now let's talk about while loop. Okay, while loop. It might be nice to actually compare. Okay, let's try to compare, shall we? Now, if you say while loop over here, you can put any Boolean condition over here, and this is so-called a state condition for the while loop. And the meaning is the same as what's really for the for loop, which means as long as the state condition for this while loop is true, stay there and execute the body of the loop until the state condition becomes false. Okay, the same meaning as before. Okay, so now why don't we try the following? If I say, let's say I is less than or equal to 4. Okay, and then you have the this is called the body of the loop, body. Okay, and then we have also, let's say print line, and then we have like this. Let me just say I, make it easy. Let's say that's it. That's it. Oh, let me also declare integer I. Okay, let's say that's it. Okay. For those of you who are familiar with the while loop, you might realize there's a logical error in the while loop already. But let's not worry about it. Okay, that's exactly what I want to reveal in just a moment. Okay. So now let's see exactly how we're going to do this. Okay. So let's try to see this. Let's try to draw the flow chart. Okay. So now we start with this line here. Okay. So we got integer I is assigned to 1. It's a statement over here. It's a primitive statement. Primitive. And then we go to check. It's a diamond over here. We go to check the state condition of the while loop over here, which is I less than or equal to 4, which can be either true or false. Okay. If it is true, what we will do is we'll simply just execute the body of the loop. Okay. So what we'll do is we'll simply say print line and then I. That's what we'll do. But what if it's false? If it is false, that means we actually don't bother to execute the body of the loop anymore. We'll simply just go out. Okay? This is false. That means exit. Okay? And now in this case, it is actually means to stay. Okay, now at the end of the loop, let's say it is true, and then you try to execute print line I. So what you will do, similar to what you did for the for loop. After the end of the loop, you go back to the loop state condition there and check it to see if you should really do one more repetition. Okay? So basically check to see if another iteration is necessary. Okay, now let's say, so this is the flow chart for the while loop. In general, you will simply just, of course, if your loop body has more than one statement, you will draw more boxes over here. But in this case, it's simple. Now, can you see any problem over here? Yeah? It never stops. It's an infinite loop. Okay, why? Why don't we try? Okay, it's a very, I tell you what, if you should you choose to use while loop, which is completely okay, this is a very typical error to have. Okay, so now let's say this. We know that I is initialized to be 1, which is, so 1 less than or equal to 4 is going to be true, right? So now, let's say after this, we're going to execute the body of the loop, print out I. At this moment, it's just 1, okay, 1. And then we go back to the same state condition here. What's I? It's still 1. It has not been changed. 1 less than or equal to 4, true. So go to true and then print out 1. So you're going to print 1, 1, 1, 1, 1, 1, 1. Never stops, because you never get a chance to update I such that I less than or equal to 4 is going to become false. Never the case. It's a very typical error. Okay? So that's why if should you choose to use a while loop, you should always make sure you have a way to update the loop counter so that eventually the state condition will become false. Eventually. Okay? Otherwise, you have an infinite loop. Okay? So now in this case, what I can do is I can put I++. Okay? You can see that's very similar to how we did for the for loop. Very similar. Okay? So now, if you do this I++ over here, I'll leave the drawing exercise to you. You can imagine that if we have I++ here, that means we just got another box over here. Sorry, I'm running out of space. You just got another box over here after print line I. And then that's going to be I++. And then this I++ will go back to the loop like this. So that means the first time I is 1, and then 2, and then 3, and then 4. When it goes back to 5, it's going to make the state condition false, and then you're going to exit from the loop. So that's while loop. So this is really, really important. Okay? And you might be wondering, okay, so let's say I do have a way to update my loop counter. What about the following? What if I say I minus minus? Would it work? Wow, it wouldn't work even though you're updating the I value. That means it's going to be 1, 0, minus 1, minus 2, minus 3, minus 4. You're getting further and further to make your state condition false. Okay? That's just another example here. No. Okay? Be careful. Okay? So now, let's think about how the corresponding for loop is going to look like. So now we simply got 4. And then you can think about this part here is the initialization of the loop counter. Okay? So what we can do, we can say integer I is assigned to 1, I less than or equal to 4, and then this is at the end. In that case, we can simply put at the third part, I++. And then we can do print line, I. Okay? So once we have done this, these two loops are completely equivalent. Okay, I'm going to show you some patterns for translating from for loop to while loop. We do have some patterns over there. But I would say here's a principle. If you have some fixed number of iterations to run through, use a for loop. If you don't really know exactly how many iterations you might have, which I'll show you in just a moment, in which case, use a while loop. Okay? It's a bit vague right now, but that's intentional. But I'll show you some. Let's see some more examples for the while loop, and then you'll get more intuition. Okay? Okay, let's go on. So now, for the while loop, so that's exactly the flow chart I drew. I tell you what, the flow chart here is only when you are a beginner to see how the loop works. As you get more and more experience, you don't have to draw a flow chart every time. But I would suggest, if you're really, really confused about how the loop you have written works, you better draw a flow chart. Okay, that's a technique. You might want to use it when you need it. I wouldn't ask you to draw a flow chart in the exam, okay? But you should really know how to do it. Okay, so now, similar idea over here. Let's say we got J is assigned to 3, and then the state condition is J is less than 103. That means as soon as J is larger than or equal to 103, which is negation, right? Of J is less than 103. As soon as it happens, we're going to exit from the loop. Before that happens, we're going to keep printing out, welcome to Java. How many times are we going to print this out? The first loop counter will be 3, 4, 5, up to 102. So we go from 3 to 102. So now how many numbers do we have? Okay. By the way, there's some formula I hope you will realize. Okay. If I say from 3 to 102, okay, how do we do that? So basically 3, 4, all the way to 102. Okay, so we call this a starting point, and this is the ending point. And the formula for, if you include both values, how many numbers are in between, including the endpoints? It would be exactly endpoints minus the start points plus 1. Okay, so that's something I hope you learned from the high school, maybe. If you haven't, learn it now. Okay, that'll be handy for you. Okay. Okay, let's go back to the slides. Okay, so now you will see that exactly we're going to go 3, and then it's going to be true, stay in the loop. And then 4, also true, stay in the loop. 5, also true, stay in the loop. All the way to, what would be the last value that's going to make it true? 102, right? Okay, good. It's going to be 102 to make it true, and then that'll be iteration 100. Okay. So you might be wondering, how did I figure out it's actually the iteration, right? So just again, it's really about observing the patterns. You can see that when j is equal to 3, that corresponds to iteration number 1. When j is equal to 4, that corresponds to iteration number 2. There's always a difference there of 2, right? The j value minus 2 in this case is going to tell you the iteration, right? So when you go to 102, that'll be exactly the 100th iteration. Okay? Again, so part of this course over here, when you try to observe the behavior of the program, that's something you want to do, to really draw a table and see how the values are changing, especially when you're seeing a new pattern of loops. Okay? For the if then else, you don't really have to do this, but for the loops, you may want to. Okay? Okay, after this, so 103, that's going to make it false. That means we exit from the loop. So exactly how many iterations do we have? We got 100. Okay, so the similar argument as before, we're going to execute the number of iteration that correspond to how many times the state condition will evaluate it true. In this case, 100 times. That means we're going to print out welcome to Java 100 times. And then, how many times do we have to check the state condition? Exactly one more time, because the last time is when the state condition becomes false. Okay? Again, this is the same idea as we learned for the for loop. Any questions about this? Okay, let's go on. Now, similar idea over here. Now, you should see that this example here is very similar to you. It's not strange, right? We did something very similar in the for loop example, so I'm not going to repeat the reasoning. Let's just think about this. If I compare this program over here, how many times am I going to print out hello world, welcome to Java? It's going to be 0, 1, 2, 3, 4, up to and including 99, right? So 100 times, okay? And now you can see that the body of the loop, the print line statement there, it does not depend on the value for count, okay? So we're going to print out welcome to Java verbatim exactly 100 times, okay? Now if you look at the second loop over there, again, you can see that the body of the loop, the print line statement there, it also does not depend on the value of the count, which is going to be 1, 2, 3, 4, up to and including 100, right? So now, are these programs going to output the same lines? First of all, how many lines is the first program going to output? How many lines, the first one? 100, right? Because when the loop counter is 0, 1, 2, 3, 4, up to and including 99. From 0 to 99, how many numbers do you have? You got 100 numbers, okay? So that'll be 100 times. Okay, guys, again, you should really try to get yourself familiar with this particular formula here. If you still got trouble, grab me during the lab sessions or office hour. I'll try to explain to you, okay? That's really important, okay? Of course, this is kind of the formula you don't have to memorize, right? If you really forget about it, just make some example and then you will find out, okay? Okay, good. So now, for the second loop over there, so now how many times are we going to print out? Also 100 times, right? 1, 2, 3, 4, up to including 100, right? So that means also print out 100 times, welcome to Java, right? So it turns out these two programs are really the same. Same number of iteration, and also, even though the loop counter values will be different, but they are not used anyway in the loop body. Okay, something similar. How can I basically have the same two programs, but I can just make a little bit tweak so that they're going to be different? I can include the count value inside the print, right? Like how we did for the for loop example. So now let's say over here, almost the same example. The only new bit I added was this count over here, the count. What's going to be the first line? Welcome to Java 0. Welcome to Java 1. What's going to be the last line? Welcome to Java 99, right? Similarly, what about the second program here? The first line is going to be welcome to Java 1, welcome to Java 2, and then last line, welcome to Java 100. Exactly the same as what I just illustrated in the iPad before. Over here, right? Well, rather than hello world, of course. Welcome to Java 0, welcome to Java 1, and then until 99, which is different from welcome to Java 1, welcome to Java 2, and up to welcome to Java 100, right? They are not really the same. There's some discrepancy over there. Okay, so you can see that loops are fundamentally more difficult than if then else. That's why we are learning this, right? At this stage. Okay. Okay, they're different because the loop body over here depends on the value, the current value of the loop counter. Okay. Again, the best advice I can give to you when you have to use the loop, make sure you write the initialization to be some value that makes sense. And also the state condition over here, make sure you really mean to write it so that it will stay in the loop as long as it is true. And also make sure you always got some plus plus to update the loop counter. Okay. Okay, again, we got primitive statements versus compound. Primitive, again, is simply the statements where you just have a single assignment. Okay, that's primitive, always a simple one. What about the compound statements? For the compound statements, basically you just want to have some nested statements. I'll give you some example. That's something you will have to do later in your labs or in your other lab test. Okay, so now, don't be too surprised if later on we may have to use something like this. You say for something over here, inside we say while, something like that. That's one example. The details are not important at this point. Okay, you will get there when you have to use it. Or you might have for loop, and then you have some if then else. Okay, you can see the if then else is the body of the for loop. Okay, or symmetrically, you might have some if then else, and then if the if is true, you're going to run some for loop. Abstractly speaking, can you see the difference between this one and this one? We're talking about we are talking about if nested within for versus for nested within if. Right? It's actually conceptually very different, right? The left-hand side, we're saying that we're going to run some iteration for a fixed number of times for the for loop. Every iteration, we're going to do some selection. Okay, that's the left-hand side. The right-hand side, we say that we will only run the repetitions, the iteration, if some condition is true. Okay, so the left and right, they are very different. Although they look maybe similar, but they are very different. Okay, so these are just examples for the compound statements, which we'll get into. Okay, we'll see examples later. Okay. Okay, so now let's do some exercise over here. So this is something you're quite familiar with from the previous exercise. So what I will do is I'll do some illustration on the Android Studio. I'll do that in just a moment. The program has been typed, so I will distribute the program to you as well after the class. Let's have a look at this. Let's try to do the following. Let's say we say system.out.println, enter a radius value. We prompt the user to actually enter a radius. And then we use a scanner to say, reading some double value from the user, and then based on what we read for the radius, multiply pi r squared, apply the formula, and then print out the area. Okay. We talk about the problem for this program here. The problem is, what if the user enters something that is negative, right? In that case, we will still actually calculate the area no matter what. If it is -3, you will actually say -3 multiply itself, multiply 3.14, which is not good, right? Now, what we want to do is, we want to use a simple while loop to say that as long as the user has entered some non-negative, means larger than or equal to 0 value for radius, we're going to keep doing this area calculation. As soon as the user enters something that's negative, exit from the loop. Okay, that's what we want to do. But how do we do that? Okay, okay, let's try to reason about this. Okay, I'll guide you through the code, maybe from Android Studio. Okay. Okay, let's say we got a circle tester, okay, over here, and then we first of all declare a scanner, okay, declare a scanner over here, and then we say system.out.println, enter a radius value. You'll prompt the user to read something, or to type something from the keyboard. And then we read the radius from the user, some double value, which can be positive, can be negative, or it can be 0. And then in line number 10, what we do is we try to check if the radius is larger than or equal to 0 or not. You can see that the radius larger than or equal to 0 over here is the state condition for the while loop, which means as long as radius is larger than or equal to 0, then we're going to stay in the loop. Otherwise, bypass, exit. Okay? So now, if radius larger than or equal to 0, what we will do is we'll say double area is assigned to, we don't apply the formula, because, okay, reaching this point, we have stay in the loop, meaning that radius is larger than or equal to 0. Okay? And symmetrically, think about it this way. What does it really mean? So this is the while loop. Okay, you can see from the indentation. What does it really mean when we actually go to the next line beyond this loop? So that means we have exit from the loop. Okay? Reaching this point, we have exit from the loop. And when we exit from the loop, what does that mean? That means the state condition here is actually false. Okay? So what does it really mean? When it is not the case that radius is larger than or equal to 0. That means radius is less than 0. Alright? So that means in that case you can just print out to say the radius is negative, so it's an error. Okay? So now after we calculate the area inside the loop body, we can just say what the area is. Okay, now you can see that there's another 2 lines over here. It's kind of very different from the I++ that we learned before. In some way, it's a more general way of specifying your loop counters. Rather than I++, think about what we're trying to do here. We want to somehow update the radius so that hopefully, eventually, radius larger than or equal to 0 is going to be negative, which will stop the loop from being executed any further. But how do we do that? Okay, so the way we do that is, since we know that this expression here, radius, depends on the value of the this expression here, depends on the value of radius. So what we do is, we update the radius value again from the user to say, let's say they enter 3, and then we calculate the area of circle with radius 3. And then we prompt it to enter another radius. If the user wants to exit from the loop, they will enter something negative. Otherwise, they'll enter something that's not negative. Okay? Let's just try to get a feel about this program over here. Okay? If I run this program over here, let's see what happened. And then we'll use a debugger to show you exactly how this is run. But let's get a feel. Okay, Gradle is still building, and then we'll see. And And this is really your first complicated program for while loop. Don't worry about copying the program. It's on the slides, and also I'll make the source code available to you. Okay, let's now play with the program over here. Okay, enter radius value. Let's try this. If I simply tell you -4, what you will do is and enter error negative radius value. Okay, it's good. And then the program has terminated. Let's do another one. Let's say I give some valid value for the first time. Okay. Let's say I give 4 this time rather than -4. You would say area is 50.24 according to the formula, and then the program has not terminated. You simply say enter a radius value. If I enter another value that's valid, i.e. larger than or equal to 0, it's going to keep calculating area once more. Let's say if I say 10, for example, it's going to say area is 314, which is the area for radius of 10. Okay. Now, what if I want to tell the program I don't want to continue anymore? I can give any negative value, -1. Okay, it's going to say error and then negative radius value. That's how the program behaves. But now we want to see exactly how this is going to be run on the program. Okay, let's see that. Okay, what I will do is I will put a breakpoint over here. And that's something you can also try when you see the source code. I want to see exactly how this expression is going to change. Okay, so that's why I put a breakpoint over here on radius larger than or equal to 0. Okay, so what I would do is I would say debug. Okay, over here. Okay, I'll run exactly the example I showed you before. First of all, if I try the following, if I try -3, okay, -3, okay, you can see that, so we are pausing over here, so now it's right before we check radius larger than or equal to 0, right before that, and currently radius is simply -3. Is this condition here going to be true or false? False, right? -3 larger than or equal to 0 should be false. So what do we expect to see? If the state condition is false for the first time, that means we do not bother to enter the loop even for the first time. That means if I say step over here, we're going to go directly to the end of the loop and say error. Okay, that's how we run the first case. Okay, okay, and then we terminate the program. Okay, that's the first one. Okay, any question about the first one? Okay, we just enter some minus value, and then it's just gonna report the error. Okay, let's try another one. What if I try another value over here, which will make us run some iterations? Let's try. Okay, let's enter some positive value to begin with. Let's say 5. And then you can see that now radius is 5. 5 larger than or equal to 0, true. That means we're going to enter the while loop for the very first time. Okay? And then we're going to say, so now it's going to calculate the area according to the radius being 5. And then it's going to calculate that and then output something. Okay? That's what it will do. And now you can see that what this will do is going to prompt the user for another input value over here, so that if the user wants to terminate the program, they can enter some negative value. Otherwise, they can just enter another valid radius value to continue with the program. Okay? So now we can say that over here, and now what do we want to enter? So what we can do is we can just go back to the console over here. If I want to enter another positive value, for example, I'll say 45, let's say. And then if I click on enter over here, 45, and then say step over, so now radius has been updated to 45. Okay, so now what's going to be the next step? So we'll go back to the state condition check for the while loop. So we'll go to step over, so now 45 larger than or equal to 0, again true, right? And then step over, step over, step over. So what you will see on the console is, you will see that we have calculated area for 45. Okay, let's say now I do want to exit from the program. How do I do that? For me as a user, I'm now being prompted to enter another value over here, enter a radius value. If I say -2, for example, If I say minus 2, and then I say, let me just click enter here, and then I'll say step over, you can see radius value has been changed from 45 to minus 2. Now what's going to happen? We're going to carry this radius being minus 2 back to the state condition check for the while loop in the beginning. Okay? And then let me just step over again. You can see minus 2 larger than or equal to 0 is going to be false. So do we continue with the calculation or not? We don't. So if I say step over, we'll simply go there and say error, negative value, minus 2. That's what we'll see. Okay? Guys, any question about this program here? It's basically using a different way of accessing the code, but now we simply just got a state condition there. Okay, let me just go back to the code slide over here. So that's exactly how this program is working. So you're going to say while some Boolean condition over here, okay? And you're going to think about what if we took out this radius equals input and next double. What if we take out this line? What's going to happen? If we take out that line, that means we have no way to update the radius value, which means if the radius happens to be positive to begin with, that means we never get a chance to update that to a negative value. It's almost like you don't have I++ for your while loop. Okay, so that's something to notice. Okay, now I want to talk about basically two variants to this while loop, and then both of them are better style in the sense that over here you can see I just hard-coded the condition for radius larger than or equal to 0. It's better to give some meaningful name for this particular variable. Okay, let's see both versions. The first version is rather easy. The second version is also correct, but it's actually tricky. Okay, we're going to see both. Okay, so now let's go back to iPad here, and I'll show you one by one. Okay, you know what? I meant to show the first one first. Okay, so let me just do it again. Oh, okay. It's negative. What about this? It could be that I got it wrong. Okay, there we go. Okay, sorry for the confusion. I'll simply just put it like that. Okay, so now we got two versions over there. They look very similar. Okay, but logically speaking, they are the same. But let's look at that very carefully. Okay, so now the first one. The first one is easy. So basically, the one I highlighted in yellow are the new parts. Okay, other parts are basically the same from the first version you just saw. Okay, now let's go over that very quickly. So we have a Boolean variable over here. I simply say the truthfulness for radius larger than or equal to 0. I'm going to store that into is positive, which means if it's positive, it's true. That means radius larger than or equal to 0. If it's positive, it's false. That means radius less than 0. Okay, it's that easy. And then we say that while the user input is positive, you can see in some way it reads better intuitively, right? So now we say that while it is the case that the user input is positive, then we keep doing the calculation. Okay? And then at the end of the loop, you can see we do this update over here. You can see it's positive over here. We are talking about the same variable. It's positive, it's positive, it's positive. And how do we update the truthfulness of the it's positive? The way we do that is by saying the same expression, radius larger than or equal to 0. Okay, that's what we have. So now let's try some values over here to see if this will work. Okay, this one's easy to see. It pretty much corresponds straightforwardly to what we had before, but the second version will be slightly trickier. Okay, let's do the first version first. So now let's try different input value. So input value, okay, let's say, what about we say minus 4? Okay, If we say minus 4, let me use maybe green over here, maybe pink. If I say minus 4, that means the radius over here is minus 4. Minus 4 larger than or equal to 0, false. So that means it's positive will be false. And then while it's positive, what's that going to be? While false, you can see, so that means it becomes false right away. That means we do not even go into the body of the loop, we just go to this directly. Okay, that's the first case. Okay. Now, what about another case over here? What about we try that, let's try the following. If we try, first of all, 5. What about 5? If we try 5 here, so now radius will be 5. 5 larger than or equal to 0 is true. So we got true over here. And then while true for the first time. That means we're going to go into the loop and then calculate the area as we did. Okay, so now we do go into the loop. And now the radius we're going to use is 5. 5 and also 5 over here. And then when we reach this line over here, we try to read another value from the user. So now what that value should be. Let's make some example here. If I give you a negative value, again, let's say if I give to you, let's say minus 2. Okay, so that means the user is going to give you, let's say over here, minus 2. Let's say if I type on the keyboard, minus 2. And then minus 2 here, minus 2 larger than or equal to 0 is going to be false. That means I get false over here. So now, if I go back to line number 4 to check this again, while false. So that means I'm going to exit from the loop, right? And then we'll go directly to this error checking, error printing message here. Okay, this one should be straightforward, right? So this one is not too bad. Questions? You okay? Yeah. Okay, now let's challenge your mind a little bit, okay? Logically. Let's see the second version over here, okay? Let me tell you exactly how I derived the second version. When I say that over here, let's talk about this while condition here. I say, as long as radius is positive, keep going. Basically, right? Informally speaking. Now, I'm just tweaking things a little bit. I'm saying that as long as radius is, rather than saying positive, I want to say not negative. They really mean the same thing, basically. So I'm saying that in this version over here, as long as the value is positive, I'm going to keep going, do the calculation. But now in this version here, I'm going to show you another version which is completely equivalent, in which case I'm going to tell you that as long as the value is not negative, I'm going to keep going. Okay, the same idea. Let's try. So now you can see that we've got another 2 Boolean variables over here. It's negative, it's negative, it's negative. Notice the critical part is over here. Not. Okay? Remember we talked about the 3 logical operators. This is one of them, which means if its negative is true, negate it to be false. If its negative is false, negate it to true. Okay? Let's try this value. Let's try some values here. Let's try exactly the same input values as we tried before. The same. Okay? So now what about the input values? Input values. Okay? First of all, let's try minus 4. What's going to happen? Minus 4. That means radius over here is minus 4. Minus 4 less than 0 is true. Okay? And then not is negative. We know that this negative over here is true. What about not true? False. Right? That means overall it's going to be false. And then what does that mean? That means we're going to bypass over here and then simply go to this line. So the behavior on this particular value minus 4 over here are exactly the same. It's just how we manipulate the logical variable over here. you can see that in this example here, we say it's positive, it's positive. And in the second example over here, we say it's negative, and then here we put a negation over there, say it's negative. Okay? So that's kind of the logical puzzle I would like you to solve. Okay? It's not too bad. Okay? So now let's try one more time. Okay? Another value. What about 5? 5 over here. So now, let's say radius is 5. 5 less than 0 is false. And then we know that it's negative, it's now false. And then we got an exclamation mark for logical negation. Not false will give you true. So that means we'll get true in this case. That means we're going to go into the body of the loop and then try to execute something, right? So we'll go inside the loop over here, and then we calculate exactly the area for 5 over here. And now, when we are reaching this stage, we want to update the value for the radius, right? So now, let's say we follow the same idea over here. Let's say -2. Okay, let's say the user enters -2 over here. Okay, now, -2 less than 0 is true. Conceptually, should we continue? We shouldn't, because it's a negative value. But let's see if the variable is going to disallow us to continue. So now it's negative, it's actually true. And then we go back to this state condition here again. Not true would be false. So that means we'll get false in this case. So that means we're going to bypass and then to this line over here. It's an error. I want you to really go over these two versions very carefully. Of course, when you try to program yourself, I would say typically you might prefer this version here, which is more intuitive. However, you might run into cases where it's actually more intuitive to program this way, where you actually put an exclamation mark over here. So you should know both. At least you should know how to trace the program for the second version. Okay? Good. Okay, we're getting very close to array, very close. Okay, basically we got all these variants over here. Okay, so the two versions. Okay, I'll let you finish the slides. So this slide over here, very simple. It's just about how we can convert between for loop and while loop. How do we do that? Let's just go over very quickly. If you want to go from a while loop to a for loop, you can simply just leave out the initialization part and the update part. What do I mean? Let's say we have this. We say while some Boolean condition B, we do something. Okay? Now you can very easily do this in a for loop. This is what you do. You simply just put a B here, but you still have to put the 2 semicolons there. So those 2 semicolons should always be there. But as I said last time, the initialization part and the update part, they can be just empty. Okay? So this one's fine. But I would say in principle, if you actually don't know exactly how many times you're going to run an iteration, you better write something like this, while B, rather than this. This one is actually easier for you to make a mistake. And remember that if you simply run something like this, I think that's also a very common mistake. If I say for integer I is assigned to 1, I less than or equal to 10, I plus plus, print line, I. So now, this program here is not going to compile, right? Because you're missing, it's not going to compile, you're missing the 2 semicolons. Be very careful. Yeah, of course, on the other hand, I wouldn't be too surprised if you write something like this. You say while integer I is assigned to 1, I less than 10, I plus plus. Conceptually, I know what you mean, but not the compiler, right? So now apparently this one is also not good. Okay? So what you really want to do is to move this out, okay, and then get rid of the semicolon, and then move this to the end. Or you can just change from while to for if you want. Okay? But be very careful. Okay? The syntax is really something you want to get right before you can write something useful. Okay, let's go for the next one. So now similarly, let's say if I have a for loop like this, that's exactly what you should do. If I have a for loop with some initialization part, some state condition, and some updates, the way I can do it is by saying move out the initialization part to outside, and also I can move the update part to here. Okay? Similar. Okay. In order to save time, I really want to cover arrays for a little bit. Let me save the state condition versus exit condition for next Monday. So next Monday, I'll start with something that's a little bit logically challenging. I'll do that next Monday. However, for now, I want to go directly to the array. How about that? Okay, so skip this part during the reading week if you want to do study. What I will do is I will go directly to array. So let me just talk a little bit more from a more general computer science point of view. So throughout your degree, basically, to learn computer science, you're learning about problem solving, logical way. So we're going to talk about problems, data structure, and algorithms. So these are the terms you will keep hearing throughout your degree. So in the coming 2030, we'll talk more about data structures and algorithms, and also in 3101, all the 3000 level courses. For this course, only this slide, I just want to introduce you a little bit about the terms. And then the only data structure we'll learn in this course is something called array. You may have learned a little bit about array, maybe back in high school or maybe in 10, 12, but the way we're going to learn this is going to be much more systematic. So I really want you to know how you can combine loops and array in a way that can be very expressive for you to solve problems. Okay, so let's define what a problem is. Basically, so we say that a computational problem is simply going to tell you what the inputs are and also what the output should be. A little bit like what a method is. You want to know what the parameters are and what the return value should be, right? You got input, you got outputs. Whenever you can tell me what the inputs are and what the output should be, it's a computational problem, okay? And then, for example, it's a very typical problem. Let's say I give you a sequence of numbers. Let's say up A1, A2, up to AN, n numbers. Now I say that output should be, I want you to figure out the maximum value in the array, in the sequence. If, for example, if I give you 1, 2, 3, 4, up to 100, I want you to figure out what's the maximum number. In this case, 100, right? But now, how do you actually define an algorithm? Algorithm is more like a step-by-step instructions, like a Java code, so that given any arbitrary sequence of numbers, you can always give to me the maximum value. Okay, that's the trick. That's the challenging part. If I only give you example, for example, 31254, you can very easily scan, and then you can tell me the maximum is 5. But what about I don't tell you exactly what numbers they are in the sequence? How can you figure out the maximum? Okay, that's the tricky part. Okay, a data structure is basically just a way for you to access and store and modify values. We will see that. So just a definition for data structure. It's a way to organize your data. And we're going to learn about how you can organize data in an array. Okay, that's what we'll see. What about an algorithm? You can think about, for now, as far as 1022 is concerned, an algorithm is simply a working Java code, which has lines of code. Okay, step by step. It's a solution to some problem. If I want you to find the maximum value, you might just give me a Java methods, which will run some loop over the input array and tell me what the maximum value is as the return value. Okay? You can just go back to this slide over here to review the terminology. Okay? Okay, now let's talk about arrays. Okay? Array is a very simple data structure. Okay? Let's now see that. So this is a visualization of an array. So now I want you to pay attention to how it is visualized. First of all, you can see that how many elements do we have in the array. Array is simply a way for you to store values. The values can be integer, can be strings, it can be person, it can be any objects. Okay? We'll see the more complicated stuff next Monday. But now in this case, we simply have an array of integers. How many integers do we have? We got 10 integers. But now, look at the blue numbers below over here. So how do I refer to different positions in the array? So this is the number one principle for you. If you want to refer to some position in the array, you start a position with 0. 0. Okay, I will talk more about why we actually start the index at 0 maybe next time. Okay, for now, let's just take it for granted. If I want to refer to the position of the array, I always start with 0. So now I can say that 750 is at position 4 of the array. But at position 4, that means it's the 5th element in the array. On the other hand, if I go for index 9, that means it's the 10th element in the array, because at index 0 is the 1st element in the array. So the indices always start with 0, no exceptions. Always start with 0, always. So now, tell me something a bit more general. If I have something like this, if I tell you that given an array of size n, just n can be any number, can be 0, can be 1, can be 2, can be 3, okay? Can be any number. So what's the maximum index? What's the maximum and minimum indices? n minus 1, maximum, right? Okay, so now it's very, so this is how you visualize this array over here. So that means the first index is always of index 0. That's always the case. And then index 1, index 2, all the way to the last index, the second last, will be n minus 2, and then n minus 1. Okay, that's how you visualize an array. Let's make it more concrete for you. So let's say over here, if n happens to be 8, for example. In this case, index 0, index 1, index 2, all the way to 8 minus 2, 6, and then 7. Okay, so 7 will be the maximum index for an array of size 8. Okay? I'll show you some more syntax in a bit. Okay, I just want to go through some definition. So later on in your lab test 2, you want to make sure whenever you want to traverse through an array, you should always start with index 0. That's a very typical common mistake. Okay? 0 is really important. And now, given an array, how do I know how long it is? There's some syntax for that. I'll go over that in the next slide. Okay, also, the types of element in an array are the same, which means if I want to say I want to have an array of strings or an array of integer, I cannot have something like this. I cannot have something like 0, 1, 2, 3, 4, 5. Let's say I have an array of size 6, okay? Now let's say the first element I want to store a integer, 3. Second element I want to store boolean, false. And then I want to store a character A, and then also a string, Alan. Okay, this is not allowed. So somehow at the declaration moments, once you declare an array, it must be of a certain type. And all the elements in the array must be of the same type. You cannot mix. Okay? Okay, an array of integer, I'll talk about declaration in just one moment. Okay, each element is associated with the integer, and then index 0, index 1, all the way to index I minus 1, depending on how many elements you have. Okay? So now, let's go over some syntax over here. So now, this is the syntax for you to create an array of a fixed size. I'll just mention that here. Syntax of array. Okay, let's try that. So now, how do you declare? If you want to declare an array, basically you just want to say what should be the type of each element. Let's say if each element is simply integer, put int first. And then this is new syntax you got to know. Open square brackets, close square brackets. And then let's say give a name of the array. Every time once you declare the type, you got to declare the variable name. Let's say integer array, IA. Okay? That's how you declare. Okay? Now, you can also assign. How do you assign an array to some value over there? Okay, so there are two ways for you to do that. Okay, let me show you the way you will use more frequently. Okay, and then we'll talk about another way possibly next time or when I see it. Okay, so now what you can do is you can say integer array over here. We already declared that it's assigned. Remember how we created new objects? Exactly the same syntax. We'll say new keyword over here. Okay, and then you have to repeat the declaration over here, integer array. Okay, and then over here you have to pass the size of the array. Let's say 5. Let's see what this really means. What this means is we are going to somehow create in the memory an array of size 5. 1, 2, 3, 4. Size 5, starting with indices 0, 1, 2, 3, 4, right? Like that. Okay, so 5 elements. So now, after this line over here, just line number 1, we're going to basically, all the values over here for all the integers are going to be default values, which will just be 0. I'll talk about default values next time, okay, next Monday. But for now, you just have to know that after this line over here, you're going to have integer array A, which is going to point to this structure over here. Okay, so now, there's several things you can do, okay? Now, first of all, how do you access? When you do access, you can say integer array A, square brackets, over here, you can pass some integer expression. For example, you can say 0. Okay? So integer array A at position 0 is referring to this value over here. This is integer array A at position 0. Okay? Now, you can also say 1, 2, 3, 4, etc. Now, the tricky thing is, how do I get access to the last elements in the array? Okay, there's a special syntax for you. So now, let me just, before I say access, let me just say another thing. What about the size of the array? Okay, so after the way for you to get the size of the array, you can say ia dot length. You gotta write out this exactly. Okay, so you're gonna say the variable name and also dot length. That's how you do it. So the syntax I talk about in this slides is what you have to know before you come to lab test 2. I can maybe have a cheat sheet for you in the lab test, on the first page, but I do not want to rely on that too much. You better know it before you come. Okay. Okay. What about the IA, the length? It's going to be returning just 5. Okay. I'll write out some example in just a moment. Okay. Now, given that we can write IA, the length, how do we refer to the last elements? It's an n-1, right? So what we can do is we can do IA at position IA dot length -1. Okay, in this case, what's IA dot length? It's 5. 5 minus 1, 4, which refers to exactly this last element here. Okay. Guys, any questions? Are we okay? Okay, now, finally, I just want to say one more thing, and then I'll show you some code in Android Studio. Okay, now, we can also modify, okay, and then we have IA, for example, 0 is assigned to 3, for example. So what does that do? Okay, so now, apparently this is an assignment. Okay, let me use a different color here. This is an assignment. Now, assigning 3 into some variable over here, you can think about IA0 is a particular position in the array. So this is IA0 over here. Okay, that's IA0. Assign that to be 3. That's what you would do. Okay, now, I only have about maybe 5 or 10 minutes or so. I want to do a very quick coding for you, and then I know that when I release the practice test for you for lab test 2, it's going to be a little bit jump conceptually, but I would say try to do as much as possible, and then I will cover more examples next week, specifically for preparing you for the lab test. But you want to struggle enough throughout the reading week. Okay, that's something I'll leave it to you. Okay, so now these are all the syntax over here. So I'll talk about iterations. So I will tell you some slides, you can just do self-study throughout the reading week. But now let's do one example together. Okay? Okay, let's now create a new class over here. Let's do that all together. Okay, so I will do is array loop tester. So public static void main. Okay, let's say we have that. And then let's now declare an array. Let's say integer IA is, let's just say it like that. So now declaring IA is an array of integers. Okay? Now let's try to initialize it. We can say IA is assigned to new integer over here of size 5. Okay? So now you'll say that assign IA to an array of size 5. So now let's try to print out the array contents right away. So now let's use a for loop. Basically, it's a very common pattern for you to use. So now if I want to print out this array over here, how should I print it? I want to print out from the minimum elements, minimum index to the maximum index, right? So which index should I start? Integer I is assigned to 0, right? That's why I said to you in the other day, 0 is very important. And then I is less than IA.length. I'll come back here in a little bit in a moment. I++. It's a very typical way of writing loops. So that means I is going to be starting from 0, 1, 2, 3, 4 until IA.length minus 1, right? Because as soon as I reaches IA.length, it's going to make this state condition over here false, right? Okay, so now that's one way to do it, or you can simply say less than or equal to this minus 1. They're equivalents. Okay, they're the same. Okay, I'll just go back to the original version, but when you watch the recording, you will see. Okay, now I can say system out of print line. I can say A. Okay, and then the counter value over here is plus AI. Sorry, IA. You can see what I'm trying to do here? I'm saying that I'm going to have this string literal IA at position, and it depends on what the value of the loop counter is currently. And then I'm going to print out exactly that value over here. But for now, it's going to be all zeros, right? As I said before. Let's verify that very quickly. And then I'll do some reassignments for you. Oh, what I should do is I should go back here, and then I'll go for array loop tester, and then right click, and then say run. Okay, let me do it again. Okay, you can see that IA0 up to IA4 is 0, right? All of them. So now, let's say we do the following. So now, I say IA at position 2 is assigned to 23. Now, let's say I execute the same block of code again. The same. What's going to happen? Well, is it going to be still the 0, 0, 0 all the way through? No, right? Because somehow you can see that. So this means assign elements at index 2 to value 23. If you think about it, you can see that over here, This is position 2, right? Assign that to some value. If you try that over here, what you will see is, let's see, you should see something different, right? You can see that it's now, okay, you know what? Let me just system.out dot print line. After executing, IA at position 2 is assigned to 23. Okay, after that, okay? So you will see more clearly. Okay, after that, you can see that 0, 0, 23, and then 0, 0. Okay, that's what you have, right? Okay, so let me see how much time I have over here. Okay, I think give me just 1 minute to wrap up. Okay, so for your lab test number 2, I'm going to give you the preparation guide this Friday, the latest. So you got more than 2 weeks to prepare. But since I only covered the very basics about array, so I'll rely on you before the next time we meet. Since we got reading week next week, so I would say I'll also give you some simple exercises to try over the reading week. You should really try that. Feel free to discuss that with your colleagues as well. And then when we come back again, the week after the reading week, I will go over a series of examples on the loops just for you to get prepared for lab test 2. But don't wait for that particular lecture that late. Okay, that's what I would suggest. Okay, lab 4 will also be due after the reading week, right? So really try to manage your time well. Okay, so I'll see you in the labs.